Meet Maya. She's in 6th grade and just got home from school with a geometry worksheet that's making her head spin. Cubes, pyramids, prisms. Her teacher wants her to count vertices, edges, and faces on all of them. Maya stares at the page and thinks, where do I even start? Well, by the end of this video, Maya and you are going to be 3D shape experts. Let's do this! Before Maya can count anything, she needs to understand what makes a shape three-dimensional. A 2D shape is flat, like a square drawn on paper. It only has length and width. A 3D shape has depth, too. It pops out into the real world. Think about a cereal box sitting on your kitchen counter, a basketball, or a fancy gift box. Those are all 3D shapes. They take up actual space, and you can hold them in your hands. That's the big difference, flat versus solid. Okay, so here's what Maya's teacher wants her to identify on every 3D shape. 3 things: faces, edges, and vertices. A face is a flat surface, like one side of a cereal box. An edge is where 2 faces meet, like the corner line of that box. And a vertex, that's where edges come together at a point. Think of the tip of a pyramid. The plural of vertex is vertices. So faces, edges, vertices. Say it with me. That's the power trio of 3D shapes. Let's start with the most famous 3D shape, the cube. Maya picks up a dice from her board game. Perfect example. A cube has 6 faces, and every face is a square. It has 12 edges. Those are all the lines where the squares meet. And it has 8 vertices, 1 at each corner. So next time you roll dice, you're holding a cube with 6 faces, 12 edges, and 8 vertices. Maya writes this down and feels a little more confident already. She's getting it. Now Maya looks at the cereal box she left on the counter. That's a rectangular prism. It looks like a stretched out cube. Instead of all square faces, it has rectangular faces. A rectangular prism has 6 faces, just like a cube. It also has 12 edges and 8 vertices, same numbers. The difference is the faces aren't all squares. Some are rectangles. So when you see a shoebox, a brick, or a book, you're looking at a rectangular prism. 6 faces, 12 edges, 8 vertices. Sound familiar? Maya's noticing the pattern. Maya flips to the next part of her worksheet: pyramids, cylinders, and cones. A square pyramid has 5 faces, 1 square base, and 4 triangle sides. It has 8 edges and 5 vertices, including that pointy tip at the top. A cylinder, like a soup can, has 3 faces, 2 edges, and 0 vertices, no corners at all. And a cone, like an ice cream cone, has 2 faces, 1 edge, and 1 vertex at the very tip. These shapes are a little different, but now Maya knows exactly what to look for. Let's try the same problem Maya is working on. Here's a cube. Let's count its parts together. First, the faces. A cube has a top face, a bottom face, a front face, a back face, a left face, and a right face. That's 1, 2, 3, 4, 5, 6. 6 faces total. Now, edges. A cube has 4 edges on top, 4 on the bottom, and 4 going vertically on the sides. That's 4 plus 4 plus 4, which equals 12 edges. And vertices? Count the corners. 4 on top and 4 on bottom. 4 plus 4 equals 8 vertices. Cube, 6, 12, 8. Now let's count the parts of a square pyramid, just like Maya's worksheet asks. Start with faces. There's 1 square base on the bottom and 4 triangular faces on the sides, 1 for each side of the square. So 1 plus 4 equals 5 faces. Next, edges. The square base has 4 edges, and there are 4 slanted edges going up to the tip. That's 4 plus 4 equals 8 edges. Finally, vertices. The square base has 4 corner vertices, plus that 1 pointy tip at the very top. So 4 plus 1 equals 5 vertices. Pyramid, 5 faces, 8 edges, 5 vertices. Okay, here's where it gets really cool. Maya's teacher mentioned something called Euler's formula.
and it blew Maya's mind. A mathematician named Leonhard Euler, pronounced Euler, discovered that for any solid 3D shape, the number of faces plus vertices minus edges always equals 2. Let's check it with a cube. 6 faces plus 8 vertices minus 12 edges, that's 14 minus 12, equals 2. It works. Try it with the pyramid. 5 plus 5 minus 8 equals 2. It works again. This formula works for almost every solid shape. How cool is that?
Let's use Euler's formula to check our work, just like Maya does on her worksheet. We'll use the rectangular prism. It has 6 faces, 8 vertices, and 12 edges. Plug them into the formula. F plus V minus E equals 6 plus 8 minus 12. First, let's add 6 plus 8, which equals 14. Then subtract 12 from 14, and 14 minus 12 equals 2. Yes, the formula works perfectly. Now Maya has a built-in way to check her answers every single time. If F plus V minus E doesn't equal 2, she knows to recount. That's the power of Euler's formula. One more shape, a triangular prism. This one trips a lot of students up, but not Maya anymore. A triangular prism has 2 triangular faces on the ends and 3 rectangular faces along the sides. That's 2 plus 3 equals 5 faces. For edges, each triangle has 3 edges, so that's 6 edges on the 2 ends plus 3 edges connecting them lengthwise. That's 6 plus 3 equals 9 edges. For vertices, each triangle has 3 corners, so 3 plus 3 equals 6 vertices. Let's check with Euler. 5 plus 6 minus 9, which is 11 minus 9, equals 2. It checks out. Remember when Maya was staring at that worksheet, totally lost? Look at her now. She can identify faces, edges, and vertices on any 3D shape, and she even knows Euler's secret formula to check her work. Let's recap. Faces are flat surfaces. Edges are where 2 faces meet. Vertices are the corner points. And Euler's formula, F plus V minus E equals 2, works for every solid shape. You've got the same tools Maya has now, so the next time you see a cereal box, a dice, or a pyramid, you'll know exactly what to count. You're a geometry